Hello everyone. In this video I would like to explain the various subsystems included in a satellite communication system. In this, first of all, you must know what are the three basic operations or the major operations which take place in a satellite communication system. They are orbit controlling, that means the controlling parameters of orbit, and altitude of a satellite, that means the position or the height of the satellite from the orbit, and the third one is monitoring and controlling of other subsystems. This is the basic block diagram for a satellite subsystem, that is there is a space segment subsystem and there is an earth segment subsystem, and in between these two there will be a communication links, or there may be communication links for the communication between these two subsystems. Space subsystem means the satellites and the spacecraft and the related items, and the earth segment is the controlling station situated on the earth. And this satellite communication system can be broadly classified into, or the basic subsystems can be classified into, first one ground segment and second one space segment. Okay, we can classify the satellite communication system into two segments, that is first one ground segment and second one space segment. And accordingly there will be two types of subsystems, namely ground segment subsystem and earth segment subsystems. These are the two basic subsystems included in a satellite communication system, that is ground segment subsystem and the subsystem associated with the space segment, it is known as space segment subsystem. About space segment subsystem, what do you mean by space segment subsystem? The subsystems present in the space segment are called as space segment subsystems, and the different types of subsystems included in this space segment are altitude and orbit control system, that is AOC subsystem, tracking, telemetry and command subsystem, it is also known as TTCM subsystem, tracking, telemetry and command. What do you mean by telemetry? Telemetry means measuring of some values, and accordingly an electric or electronic signal may be generated and it will be transmitted to a remote location, that is known as telemetry. And the next is power and antenna subsystem, and finally transponders. These are the basic subsystems included in the space segment. What are they? Attitude and orbit control subsystem, AOC subsystem, tracking, telemetry and command, that is TTCM, power and antenna subsystems, and finally transponders. And in earth segment subsystem, the subsystem that is present in the ground segment, and it has the ability to access the satellite repeater in order to provide the communication between the users. This segment provides the communication between users, and this segment also known as ground segment because it is situated on the ground or situated in the earth. So it is also known as ground segment, and it performs basically two functions. These are transmission of a signal to the satellite and reception of a signal from the satellite. These are the two basic functions of a ground segment or an earth segment. And each or the earth stations are the major subsystems that are present in the earth segment. The earth stations is the major component of the earth segment. Okay, it is also known as ground segment, and it has basically two functions, that are transmission of a signal to the satellite and reception of a signal from the satellite. And whereas in space segment, the first section is attitude and orbit control system, it is abbreviated as AOC subsystem. Sometimes satellite may deviate from its orbit due to some external forces like gravitational force from sun, moon or other planets, and this AOC subsystem consists of rocket motors, and they are capable of placing the satellite into the right orbit. Whenever it is deviated from the respective orbit, the AOC subsystem will replace or will rectify its position and keep the satellite in the original or in the correct orbit. That is the main function of AOC subsystem, and this AOC subsystem consists of two parts, that is attitude control subsystem and orbit control subsystem. Attitude means a position relative to some point, that is like altitude itself. Altitude has the same meaning, some position, like AOC subsystem. It has two control subsystem, that is attitude and orbit. So respectively this can be classified into two parts as attitude control subsystem and orbit control subsystem. Coming to attitude control subsystem, attitude means what? It refers to some orientation of satellite in space. That is a position of satellite in space or orbit. It is referred to as attitude. And attitude control is necessary to ensure the directional antennas point to the proper direction, because we have to kept or we have to keep the position of satellite to ensure the directional antennas, or the ensure the beam of or the signals from antennas or to the antennas. So this attitude control subsystem takes care of the orientation of satellite in its respective orbit. It controls the position or the orientation of satellite in a particular orbit. And for this orientation, or for keeping satellite in correct orbit, there are two methods to ensure the satellite in its stable in the orbit, that are spinning satellite stabilization and momentum wheel stabilization. It is also known as three-axis method. These are the two processes that ensure the satellite that is stable in the orbit, or the to ensure the correct orientation of satellite in an orbit. It is done by two. It is done by two methods, that is spinning satellite stabilization and momentum wheel stabilization. Coming to spin stabilization, this type of stabilization may be achieved with cylindrical satellites. Here the geometry of satellite is cylindrical, and the satellite is constructed so that the mechanically balanced about one particular axis, and it is then set spinning around the axis. And due to this spin axis, it gets stabilized and the satellite will point in the same direction. And satellite of this type is known as spinners. And this type of satellites that are used to stabilize in its orbit by using spin stabilization, and that having geometry cylindrical geometry, that type of satellites are known as spinners. This is the diagram to represent the spin stabilization, where the spin axis is adjusted parallel to the north-south axis of the Earth. Here we can see the cylindrical satellite and its axis made parallel to the north-south axis of the Earth, and the cylindrical satellite is rotating around the Earth through its orbit. This is known as spin stabilization. And coming to momentum wheel stabilization, it is also known as three-axis method. The momentum wheel stabilization is also known as three-axis method, and in this method the satellite can be stabilized by using one or more momentum wheels. Here three axes are used, so it is also known as three-axis method. And the advantage or the main the advantage of this method is that the orientation of the satellite in the three axis will be controlled, and there is no need of rotating the satellite's main body. Like spin stabilization, there is no need of rotating the satellite's main body. That is a main advantage of this three axis method. And coming to the terms, or coming to the name of three axis, it is known as roll, pitch and yaw. That is RPY axis. The roll, pitch and yaw. These are the three axes that are represented in the momentum wheel stabilization method. And this axis shows the direction relative to the Earth, and all the three axes pass through the center of gravity of the satellite. This is the main feature of this axis: roll, pitch and yaw. And this is the figure representing the three axis method. We can see three axis, that is yaw axis. It is known as yaw rotation, and it is pointing towards the Earth center, and this axis represents the roll axis. And the third axis, this is a pitch rotation or the pitch axis, and it is normal to the Earth, and this yaw axis is pointing towards the center of the Earth. And the detail about this roll axis, it is considered in the direction in which satellite moves in the orbital plane. and that direction is represented by roll axis, whereas yaw axis is considered in the direction towards the earth. And finally, the pitch axis is considered in the direction which is perpendicular or normal to the orbital plane. And in this type of stabilization method, there are two gas jets are used, and each axis contain two gas jets in order to stabilize its position, and they will provide the rotation in both direction. In three axis, the two gas jets provides rotation of the satellite. Okay, and the first gas jet will be operated in some period of time, and after that the second gas jet will be operated in the same period of time. And when the satellite reaches to the desired position, the second jet will stop, and the motion of the satellite in that direction. In order to achieve some direction, the gas jet propels, or due to its propulsion, the satellite rotates, and because of this rotation, the satellite can achieve, or the this method or this type of stabilization method can achieve the stabilization or the orientation in a stable position in a particular orbit for the satellite. And coming to next subsystem, it is orbit control subsystem. In addition to having this attitude control, we have to control, or the satellite have to be controlled in a proper orbit. And in addition to that, it is important for a geostationary satellite, that is, it should be placed in the correct orbital slot. And the orbit control subsystem is useful for, or in order to bring the satellite into its correct orbit position whenever the satellite gets deviated from its orbit. And we have already learned about the, due to the equatorial ellipticity, or due to the shape of the earth, or due to the elliptical geometry of the earth, it causes some deviation or the drift of satellites from its orbit. And the procedure of bringing satellite back into the correct orbit, it is known as station keeping maneuvers. It is known as orbit control subsystem. And TTCM we have already learned, that is tracking, telemetry and command subsystem, present in the earth station, monitors the position of the satellite, and whenever there will be, or whenever if there is any change in the satellite orbit, it sends a signal regarding the correction to the orbit control system, and automatically it will resolve that issue and bring the satellite into its correct orbit. And likewise, the AOC subsystem, or attitude orbit control subsystem, takes the satellite position, or keep the satellite in its right position or orbit. In tracking, telemetry and command subsystem, it is present in both satellite and earth station. The telemetry, or telemetry means a measurement at a distance, that is measuring the values at a remote location and send the corresponding electrical signal to a particular remote station or receiving station. It is known as telemetry. And the main operations involved in a telemetry is generation of an electrical signal which is proportional to the quantity to be measured, and second one, encoding that electrical signal, and finally the third operation is transmitting this code to a distant earth station. These are the major operations, or three basic operations in a telemetry operation. And the data that are transmitted as telemetry signals include what are the information for a satellite communication, that is attitude information, environmental information, that is like magnetic field intensity and its direction, the frequency of meteorite, some metal parts that may fall onto the earth's surface from the space, it is known as meteorites, and the spacecraft information such as temperature, power supply, or the stored fuel pressure, that are the data included in the telemetry signals. And the telemetry subsystem transmits about the satellite to the earth station. That means they have to transmit information about the satellite to the earth station, and while the command subsystem, that is TTCM, tracking, telemetry and finally the command subsystem, receives the command signal. According to the electrical signal, there will be some command signal from the earth station in response to the telemetered information, and this command subsystem demodulates and decodes the command signal and routes these appropriate equipment needed to execute the necessary action. According to the telemetered information, there will be some command signals, and accordingly, based on these command signals, they will execute the necessary action. And generally the control codes are converted into command words, and these command words are sent in form of TDM frames. Okay, and initially the validity of these command words are to be checked by the satellite. This is about telemetry and tracking, telemetry and commanding subsystem. And after this process, these command words are sent back to the earth station, and finally it again checked, and if the station is also receives the correct command word, then it will send an execution, or they send an execute instruction, and correspondingly the satellite will, or the station will execute the command. And the tracking of the satellite, that means the in order to find the position of a satellite, that is known as tracking, and it is accomplished by having the transmit beacon signals which are received at the earth station. By sending some continuous signals, they can track the satellite. And this tracking subsystem that is present in the station will keep a tracking of the satellite, and it performs functions like locating the satellite in its initial orbit and transfer orbit. It will track the position of the satellite. That is the main function, or that is the main duty of tracking system. And next system is power system. In order to perform the function, the satellite must have some power supply, or in order to operate continuously, or during its lifespan, it definitely needs some power system. And this is a vital subsystem, and most of the power systems in a satellite are controlled or are operated by solar cells or rechargeable batteries. And we know solar cells will generate lesser power, and in order to generate more power, we require a group of cells or solar arrays. Okay, and in sometimes, that is during eclipse time, it will be very difficult to get the power from the sunlight, and in that particular situation it will get power from the rechargeable batteries. And these are the major things about the power system. That is, the main content is that in order to function, satellite must require some power sources, and this includes in the power system. And in antenna system, coming to antenna subsystem, the antenna subsystem of a satellite communication can be classified into two, as earth station antennas or satellite antennas, and or spacecraft antennas. And the satellite antennas perform two types of function, that is receiving of signals which are coming from the earth station, and the transmitting signals to one or more earth station based on the requirement. That is likewise any antennas, also in satellite subsystem or antenna subsystem. In a satellite communication, the functions of antenna, or the two major types of functions in antenna, or the major functions of satellite antennas are receiving signals and transmitting signals. And there are different types of satellite antennas. The main four types are wire antennas, horn antennas, array antennas, and reflector antennas. According to the requirement or the function, different types of antennas are used in an antenna subsystem. Wire antennas are mainly used for high frequencies in order to provide communication from TTCM subsystem, tracking, telemetry and command subsystem, and it is omnidirectional antennas, and it is suitable for covering range and to provide signal through in all direction. Whereas horn antenna is used to cover more area on earth, and the same feed horn can be used for transmitting and receive signals, and there will be a duplexer that can separate the transmitting and receiving signals. And where we use array antennas for multiple beams, and there will be some beam shaping equipments, and it can be achieved by using some array of basic elements. And finally, the reflector type of antennas, it is used for focusing mechanism, which concentrates some energy in a particular direction, and mainly they are highly directional antennas. Okay, that's all about the basic subsystems, and the other topic included in subsystems of transponders that will come in our next video. Okay, thanks for watching.